All right, so 3.7, sinusoidal function context and data modeling. So with every function that we've done, we seem to have this section of context and data modeling, which involves looking for the function that best suits the table of information we have. So here's my data. We see there's a couple of questions we need to do in order to figure out what to do. Now, the first thing I want to label on my data are my minimum and maximum values because those are very important for a sine or cosine function. So I can see here I have a maximum occurring here. We notice that I go from 184, 225 to 172. I then have another one over here and one more down here, which means I'm going to say my maximum, I'm going to give it an estimate of about 225, right? I have a little over, I have a little under, and then I have at 225. Then my next thing to look at is going to be my minimums. Well, there's a minimum right there, another one, and one more. So with my minimums, I have 98, 102, and 101. So we'll say just about 100. Okay, so now that I have that data written down, I'm going to go ahead and start going through those questions, right? Um, the min and max are very important for these kinds of questions. So first thing it says, estimate min period. Well, I can see that I have a maximum at 80 and I have a maximum at 20. So remember that in the function, the period is going to go, it's the complete cycle. So from maximum to maximum, from minimum to minimum. In this case, I have the maximum first, so I'm just going to do maximum to maximum. So I have one at 80 and another one at 20, meaning that my difference is going to be my period, which is going to be about 60, right? Which means then that my frequency, which is the reciprocal, is going to be 1 over 60. Okay, so that's the first part done. Second question says to estimate the vertical shift or to find where the midline is. So the midline, remember, is going to be a halfway point between the maximum and the minimum. So what I'm going to do is I'm going to take the information that I got earlier and I'm going to say, okay, well, 225 plus 100, and I'm going to divide that by 2. That's 325 divided by 2, which is going to be 162.5. So that is where my midline is. So y equals 162.5. Now to figure out the amplitude, well, the amplitude is going to be basically from the midline to the maximum or to the minimum. I can do either one. In this case, the easier one is going to be to go to the minimum just because it's 162 and a half to 100, right? That's easily determined to be 62.5. So now question 4 says using the above information, create a sinusoidal function model. So now I need to create the model route. In this case, I can do sine or cosine. It doesn't actually matter. I'm assuming on your AP exam, they will probably ask you to create one, or if it's on an FRQ, they may ask for both. You will have to know how to do this, which we're going to do together. The first thing I'm going to start off with a sine function. Okay, so we're going to say f of x equals sine, and then we're going to start filling in all our information. Well, remember, I'm going to write these on the side that it's a sine b theta plus c, and then on the outside is that plus d. It gets a little cut off. And cosine is the same thing, just instead of sine, it's cosine. So my a is my amplitude. Well, that's 62.5. We've got that figured out. Now, I need to figure out pretty much everything else, okay? So the first thing I want to do is find out where my graph is starting to know if I'm going to have a shift somewhere, right? So what I need to do is I need to remember that with a sine function, my graph starts at y equals 0. So I need to look from my beginning points to find out where my y equals 0 is. Well, in order to do that, I need to kind of find my halfway point for going forward, right? I can't go backwards before I go forward. So Between my maximums and my minimums, I see I have a maximum at 20 and a maximum at 50. So somewhere between there, we'll say around here, maybe. It's like 35, right? Then again, from the minimum over to the maximum, I'll probably cross over at 0 at around 65. And then from, this one is a little bit difficult, but from 80 down to 100, I'm probably going to hit it at around 95. Then we're going to have 125, 155. So notice that basically from my points, my minimum or my maximums, I'm moving 15. So if I'm at 20, which is my starting, and I go back 15, that puts my first 0 at 5. That means that my function is going to shift 5 units to the right, right? Because remember that my default sine function starts at 0, 0. Okay? So that means that I'm going to have x minus 5. Remember that it's a horizontal shift or phase shift, as they call it with sinusoidal functions. So it's going to be the opposite. So it is minus 5. And then I want to figure out the plus d because that's the other easy one. Remember that d is just going to be whatever my midline is, which is 162.5. So the only value I'm missing is the b. Well, remember that periods are equal to 2 pi over b. So I know what my period is, so I can go ahead and just solve for b in this case. And I would get 2 pi equals 60b, divide by 60, and I get that b equals pi over 30. So this is what my sine function will look like based on the data that I've gathered from my chart and everything. So at this point, you should pause the video and try to figure out how to get cosine. So cosine is going to be the same, except the only difference is that cosine starts at the maximum, right? A cosine function starts at the maximum value. So you'd want to actually start looking at your first maximum that you have as your start of your cosine graph. So that is my hint to you. You can pause it. We will actually do the cosine one in class together so that you have the understanding. And number 5 is using the calculator. So when you put it in your calculator, all the data, and you do the stat and everything, we're going to go over that in class as well. But the function that you get when you calculate in the calculator, because I have it done on my calculator, is going to be 55.6 sine of 0.105x minus 0.480 plus 156.089. So the data definitely looks different, but keep in mind that this is a more accurate answer, right? Ours was done basically by just kind of estimating data, right? By estimating a maximum, estimating the minimum, while your calculator takes the data and actually calculates it. So it gives you more exact values. That being said, our answers are not that far off. And you might be looking at this sine 0.105x minus 0.480, but keep in mind that most likely if you distributed this pi over 30 to x and 30 and 5, you will most likely get something very similar in fractions. Okay, and that is the end of 3.7. So make sure you try and do the cosine for number 4 and check out the practice at the end of these notes as well. In this unit, you are now actually getting a test prep section at the end of the notes. So make sure that you're doing those as well to help you study for the AP exam.